For a frequency more than 40 megahertz, we know we cannot send it either by ground wave propagation, or we cannot send it by sky wave propagation. It will puncture the atmosphere and go up. We have two ways. Number one, line of sight propagation, where antenna should be quite higher from the earth, so that it is quite away from the earth and there is no induced wave parallel to the propagated wave, and there is no short circuits. That is one wave, and that is from antenna to antenna. Line of sight should be clear. There should not be any obstruction on the way. Otherwise, it will stop, because it has no tendency to bend round the corner. It cannot bend round the corner. Okay. Because it is very powerful, it goes straight. We use this property for another type of reflection, and that reflection is by anything in the space. This is earth and space around it. We are sending from this station, we are sending the waves, and this wave we are not sending it straight, but we are sending it with certain angle. So with this angle, this is going this way, penetrating the atmosphere, and it goes up and up and up. Suppose here we have a satellite, and this satellite is rotating about the earth. It will go and strike. We aim it in such a way that it will strike this satellite. So it will go strike the satellite, and as a natural phenomena there will be reflection. If the satellite is inert, not active, but that reflection which will bring it back to the earth, that reflection will be quite weak, and there will be so many other defects in that type of reflection by inert satellite. So we do not favor inert satellite, we have active satellites. Now, what is this active satellite? What is the activity in that? First, location of the satellite. This satellite must be a geostationary satellite. Geostationary. We all know that geostationary satellites are such which are not changing its position with respect to Earth. If I see them there, they will remain there forever, because my rotation on the Earth and rotation of this satellite, these two are rotating with the same angular velocity. So whenever I give a direction, it will always remain there, neither this way, nor here, nor there. That means if I am sending my wave to that satellite, it will always strike that, because my station is rotating, the satellite is also rotating, and both will remain as a set. So it will always strike this satellite. And what is the condition for that? The condition for that is that satellite should be in geostationary orbit, and such satellites are known as geostationary satellites. Now it strikes that satellite. This satellite has got an arrangement of a repeater station. What is that? It has got a receiver, so that it will receive the waves. Then it has got an amplifier, so it will amplify. Then it will change the frequency, and transmit back. So it is having action 1, 2, 3, and in between it will change the frequency. Now this giving signal from Earth station to satellite is known as uplinking. When this satellite transmit it back using its transmitter. It will transmit here, it will transmit here. All this range is receiving signals from this transmitter everywhere. Any receiver here can receive this signal being transmitted by the satellite. So, what is the range? Answer, this is the range. More than 1/3 of the earth can receive this. This is the biggest range, very big range compared to skywave, nothing to say about ground waves. So, this gives us a very big range. And this type of transmission, propagation, going in the space, coming in the space. So, this is a space communication. And what we are using? A satellite. So, we give it an adjective that this is a satellite communication. So, propagation, space wave propagation, space wave propagation. Communication, satellite communication. So, in space wave propagation, there was one line of sight communication that we were using on the Earth's surface, and there is one this space propagation. We are using it for the satellite. This is satellite communication. This is helping us in our GPS system. This is helping us in our TV transmissions. Everybody has got a dish antenna here. Just on the roof of his house, this dish antenna is getting signal from satellite, and we have seen how much is the frequency that is in the previous lecture. Okay. So, this way we can receive it. So, this is known as satellite communication. How much is the frequency used? More than 40 megahertz. And it has to go to 12,600 kilometer. So, it has to be very energetic. It is, because the frequency is so high. It has got lot of energy. It can go and come back. Okay. Then, this satellite communication, if I send a signal from here, can I receive it here? Answer is no, I cannot, because from this to this is the range only. Then, if there is a match in Brazil, in Argentina, here is India, can't I see that? Answer, we have a solution for that. And that solution is the global communication. 1, 2, 3. There are 3 satellites. The signal goes from here to this place, and this will send a special frequency here. This will send a special frequency here, and they will send a special frequency. These 3 are connected with each other by different transmitter and receiver circuit. This signal which goes from here, it is sent to this, it is sent to this at different frequencies. Now, it is also beaming towards Earth this way. This is also beaming towards Earth. Now, each of them is covering more than 1/3 of the Earth, and the total Earth is covered. This is the system what we employ when we are having Olympic openings, Olympic closings. All the world is able to see that, and this is global network, global communication. Basically what it is, space wave propagation. Then it is a satellite communication, then we make the systems like that. In our GPS system also, we have got 4 satellites, and they are always connected with my mobile, and they are tracking me that where I am. Then they will see my very small movements with help of that communication, space wave communication. Okay, so this is all about space wave communication, that was line of sight as well as satellite.